Alrighty, we're on Notes 4 of Unit 5, and this time around we're taking what we know about two-step equations and adding just one more little detail. I want to make sure you know how to use negatives in equations, and when you see them in a random problem, you know how to deal with them. They're really not that scary, but it's worth taking the time to make sure you're totally on top of it. So, let's dive on in. Before we even start, I need to make sure you're totally comfortable with negatives. So that means being able to do all four operations: addition, subtraction, multiplication, and division. If you know how to use those rules, you'll know how to solve equations. So the first thing I want you to do is pause your video and try solving these 8 problems right here. If you can do that, I know you can do this. All right, go ahead and pause, and I'll show you the answers in a second. Okay, let's go through these. First, I have negative 3 plus 5 is positive 2. 4 minus 8 is going to be negative 4. Here I have negative 2 times 10. Well, I have one negative, so when I multiply, my answer is going to be negative 20. The negative stays. Same thing here. I have one negative, so when I do 12 divided by negative 4, my answer is going to be negative 3. Next to it, on the next row, I have negative 6 minus 4. These are going to combine and give me negative 10. 8 plus negative 2 is going to be positive, but it's like subtraction. I'm going to get positive 6. Over here, I have one negative and negative 5 divided by 5, which is going to give me an answer of negative 1. Finally, negative 6 times negative 2, I finally have two negatives being multiplied together. And if you remember, when I multiply two negatives, they go away, giving me a positive 12. I also want to make sure you know how to identify terms. Really quick, go ahead and pause again and see if you can underline each term in this expression below. Okay, I'll go ahead and underline mine as well. I have this negative 3x here. I have 5y, this, that, and I can keep on going. Remember, my terms are everything between the pluses and minus signs. But we're going to look at that in just another way below. I want to take another look at that expression you underlined above. We're going to underline each term a little bit differently this time. Watch closely. I'm still going to get my negative 3x the same way, but this time I'm going to underline a little bit more. What do you notice I'm also underlining with each one of my terms? I also underlined the operation on the left of each term. But why? Our expression has negative terms. And we absolutely have to account for them. You might be wondering why we treat subtractions like they're negative signs. That's because they're the same thing. Here's why. So, I have 3 minus 5 is negative 2. And I have 3 plus negative 5 is also negative 2. That means when I have something like negative 3x, this is a positive 5y. I have a negative 2, a positive 10x, a negative 3z, a positive 4, a negative 22x, and a positive 10y. This subtraction here is the exact same thing as a negative sign. So when you're looking at an expression, looking at an equation, and you see a minus next to a term, you should think of that as a negative term. So, again, this is a negative 3x. The first term can just have a negative sign. A negative 2, negative 3z, negative 22x. Because this is a plus here, we treat that as a positive 10, or a positive 10x, a positive 5y, and so on. So, negatives and subtraction are the same. That's important to know when solving equations, so we can perform the right opposite operation. Remember, each term takes the sign on the left. In the checking understanding below, I want you to identify whether each term is positive or negative. And I'll show you what I mean. Going back up to this expression, I'm going to use an n to identify terms as negative and p to identify terms as positive. This first term is negative. The second term is positive. I have negative, positive, negative, positive, negative, and positive again. Below, you'll be able to identify each term with an N for negative and a P for positive. Go ahead and try those, and when you're done, flip to the back. Okay, let's flip to the back. Okay, so we identified negative terms. Now let's do negatives in equations. Basically what it comes down to is that subtraction sign doesn't just go away. Identifying where negatives in equations can help us Identifying where negatives are in equations can help us avoid making mistakes in some unusual situations. Namely, when the x term is not in front. And if you look at these equations here, on all of them, my x term is actually second in line. It's still on the inside. We still have to dig down to our x, but it's not on the edge of the equation anymore. Now it's on the inside. We still work from the outside in. We eliminate the outside term with an opposite operation, and then the inside term. Before solving the equation below, we should identify whether each term is positive or negative, just like we did on the front. So, in this first one, I only have positive terms. This is a positive 2, a positive 3x, and a positive 12. The second equation has some negatives, though. This is a negative 5, and this is a negative 10x. I also have a positive 35 on the other side. On my parentheses equation, I have a negative 6, a positive 4. I have a negative x, which is going to be something interesting we'll see in a little bit. And on the other side, I have a negative 24. Here, I'm going to call this a negative 3. I'm going to treat the negative as being with the 3 on the bottom, and that this whole thing is a negative term down here. On top, I have a positive 5 and a positive x. My 2 on the right is also positive. Okay, this may seem like a lot of extra work, but taking the time to identify your negatives will guarantee that you get the right answer. Now that we've identified each term, let's go ahead and solve. Okay, so the first one is just like what we've seen before, except now that the x is on the inside of the equation. So I'm going to subtract my 2 from both sides, and I wind up with 3x. I bring the 3x down, equals 12. Solving this is as simple as dividing both sides by 3. When I do that, x equals 4. Okay, now we're going to deal with negative terms, our favorite. So, I have negative 5 minus 10x equals 35. I still have to get rid of this negative 5 first, and remember, negatives are the same thing as subtraction. So, the opposite of that subtraction is going to be addition. To get rid of this negative 5, or any negative number, I want to do addition to get rid of it. So, I'm going to add 5 to both sides. Okay, that eliminates the 5 here. And then I do 35 plus 5 gives me 40. I bring down my equal sign, and my negative 10x. This negative does not go away because it's a negative term. It's not just a subtraction, it's a negative term. So, I divide both sides by negative 10. That leaves me with x. I have 40 divided by negative 10. That's going to give me a negative 4. Alright, going to keep on going. Here, I have negative 6, which I can divide both sides by. That cancels out these, and negative 24 divided by negative 6 is going to give me positive 4. Then I have 3 minus x equals positive 4. So now I'm going to subtract 3 from both sides. And notice I have 1 on my right, but on my left I have negative x. I ask you then, are we done? We're actually not. And the hint to solving this correctly is remembering what number is in front of our x. When we just have an x by itself, we think of there being an imaginary 1 there. And that 1 is still there even if we have a negative number. So I want us to think about having a negative 1x there. So, to get rid of that negative 1, we're going to divide both sides by negative 1. eventually leading us to have x equals negative 1. Really, all that's happening when you have a negative x, you're transferring your x over to the other side. You can move your x over to the other side. I'm going to pause, let that sink in. We moved our x over by dividing both sides by negative 1. It just changes the sign on the other side. Okay, now that that's settled in, let's go ahead and solve this last problem. Remember how I circled the negative 3 up here? I'm going to eliminate this negative 3 by multiplying both sides by negative 3. So, to get rid of the negative and the 3, I multiply by negative 3 here, and I multiply by negative 3 there. That will get rid of all this, and on my right, I have 2 times negative 3, which gives me negative 6. On my left, I have 5 plus x. So, to get rid of that 5, I subtract it from both sides. I have x, I bring my x down, and I have negative 6 minus 5 is going to give me negative 11. We had a positive x, so I don't need to do anything weird with signs. I just have a positive x equals 11. Okay, I know this is a lot. I want you to go slowly with each of these problems and to think carefully about what sign you have in every single situation. Each of these questions has some element you might see in future problems. Go slowly and think carefully about which operations you use at any given time. So, as always, I have a checking understanding at the bottom. Do the best you can with these problems, and please let me know if you need any help. Thank you very much, and have a wonderful day.